Good day. We're looking at another sheet that you've seen before in previous years, so this is meant as a reminder. You're going to see it now, and this sheet will come back into play in Chapter 5 when we look at reactions. So physical changes tend to be reversible. In physical changes, our chemical formulas stay the same on the product and reactant side because the elements have not rearranged. They haven't broken apart. They haven't come together. So we end up with the same materials that have the same properties. And these things are often reversible. All changes of state are physical changes. And we know physical changes like change of state are easily reversed. You add heat, you can melt ice. And you take away heat and you can freeze it. Turns out if you put pressure on ice, you can actually melt it. Those of you who skate probably already know that. If you break something, well, that may not be so reversible, but you have not altered the chemical composition. Grinding really is a form of breaking. So when you're crushing things into smaller bits, they're still made of the same material. Dissolving and distillation are physical changes. So dissolving means you're making a solution, and distillation means you're undoing that work. You're separating it into a solvent and solute. These are examples. Dissolving, right from there, physical. Melting, right from there, physical. And our formula here are the same. Formula here are the same. All that's changed are the states. Now to a chemist, chemical changes typically are more interesting because you are making different materials, and that means they have different properties. You end up with something different. If we look at formulas, the formulas will have rearranged. Things will have broken apart or come together. Chemical changes are often irreversible. That means they won't be reversed. Well, in Chemistry 12, much of the course is talked about reversible reactions. So you'll say, hey, I'm always lying to you, get used to it. If we see a color change, we're going to bet it's a chemical change. Energy being produced or absorbed, so if we mix chemicals together and suddenly gets hot or suddenly gets cold, then we're going to say, I bet that's a chemical change. A precipitate forming means you mix things together and you make a material that doesn't dissolve. It sits there as a solid, and initially things may go cloudy, and if you let it sit, it settles out. If you mix things together and you're not adding heat, and suddenly you get fizzing or bubbles, that means you made a gas, chemical change. Anytime you see burning, you know for sure it's a chemical change. That's a reaction with oxygen. So, first chemical change you would have seen in grade 8, sodium thrown into water. The hydrogen that's produced catches on fire, and then it blows up a beaker. So you got a few changes going. The breaking of the beaker would actually be physical, but the burning and the little explosion would be chemical. Calcium carbonate, with a bit of heat, we can gently coax it apart and free up carbon dioxide gas. Here we see we had one compound, now we have two compounds. Things have, in this case, broken apart, recombined, and therefore it is a chemical change. Don't forget you have to know the states of matter and their symbols, and all these letters are in lowercase. Do not put them in capital letters or they will be marked wrong.